So here in this problem, we need to resolve the given rational fraction into partial fraction. So let us begin. Now clearly, we first observe here that there are two factors in the denominator, and both of the two factors are quadratic in nature. However, what we can do, we can further factorize x squared plus x minus 2. So x squared plus x minus 2 can be factorized by splitting the middle term. So we have the middle term, which can be expressed as 2 minus 1 times x minus 2. The way we have chosen 2 and 1 here is that we have taken this constant 2 and multiply it with the coefficient of x squared, which is 1. So 1 times 2, that's 2. So we'll have to take factors of the number 2 in such a way so that they add or subtract to give us the middle term. And that means we now have x squared plus 2x minus x minus 2. From the first two terms, we can take x as the common factor. So we have x times x plus 2. And from the third and the fourth term, we're going to take negative 1 as the common factor. So we have negative 1 multiplied to x plus 2. Now we are left with two terms. Both the two terms have x plus 2 as the common factor. So if we take that as common, then we are left with x minus 1. So x squared plus x minus 2 can be also factorized as the product of x plus 2 times x minus 1. Which means that now our rational fraction can be also expressed as x divided by x minus 1 times x plus 2 multiplied to x squared minus x plus 2. Fine. So this will be equals to, so what we'll do, we'll suppose that since there are now three factors in the denominator, so let's say there are three partial fractions. So the first one will be a over x minus 1. The second one would be b over x plus 2. And the third one is going to be cx plus d. The reason behind this is because we have a quadratic factor x squared minus x plus 2 in the denominator. So our goal will be to find out the value of a, b, c, and d. We're going to label this as equation number 1. Fine. So what we'll do, we'll take equation number 1 and then multiply both sides with the denominator x minus 1 times x plus 2 times x squared minus x plus 2, such that we get x on the left hand side, and on the right hand side we have x plus 2 multiplied to x squared minus x plus 2 times a. Then we have x minus 1 multiplied to x squared minus x plus 2 times b. And then we have x minus 1 times x plus 2 times cx plus d. What we'll do, we will expand the right hand side and we're going to combine all the like terms. So this is going to give us x cubed will be multiplied to a plus b plus c, followed by the next term, which is going to contain x squared, and its coefficient will be a minus 2b plus c plus d. Then we have x. So x is going to have the coefficient 3b minus 2c plus d. And then finally we have the constant term, so that's going to be 4a minus 2b minus 2d. So there are four terms on the right hand side. The first term contains x cubed, second term contains x squared, third term contains x, and the fourth term is the constant term. However, on the left hand side we only have a single term, which is x. However, we can rewrite it as 0 times x cubed plus 0 times x squared plus 1 times x plus 0, so that this left hand side also has got four terms. The reason why we're doing this, that because we're going to compare both sides, and on comparison and equating both sides we're going to get four equations. The first one will be a plus b plus c, that will be equals to 0. We're going to label this as number 2. So this is obtained by equating the coefficient of x cubed on the right hand side with the coefficient of x cubed on the left hand side. Then we have a minus 2b plus c plus d. So that's the coefficient of x squared on the right hand side. So this will be equals to 0, which will be equation number 3. And then we have 3b minus 2c plus d equals to 1. So let this be equation number 4. And then we have 4a minus 2b minus 2d, so this will be equals to 0. So let this be equation number 5. So we have four unknowns, a, b, c, and d, and we have 4 equation. So we can solve these 4 equations to obtain the value of a, b, c and d. That I'll be leaving as an exercise for you. So I'll state the values here. So a comes out to be equals to 1 over 6. The value of b, that's 1 over 12. The value of c is negative 1 over 4, and the value of d is positive 1 over 4. Now that we have the value of a, b, c and d, we're going to substitute this back in equation number 1, such that we have x minus 1. So x minus 1 times x plus 2, so that's nothing but x squared plus x minus 2 multiplied to x squared minus x plus 2. This will be equals to, so we have a over x minus 1, so a is 1 over 6, so we have 1 over 6 multiplied to x minus 1. Then we have b, so b is 1 over 12 times x plus 2. Added to cx plus d, so c is negative 1/4 and d is positive 1/4. So let's rewrite it in a compact form. So we have negative of x minus 1 divided by 4 times x squared minus x plus 2. Right. So this is how we have successfully resolved the given rational fraction into 3 partial fractions.